Okay, so let's start. So now the third and last speaker of this session is Igor Karuza. Igor works at a company called IGEA in Croatia. He's a GIS specialist and is going to introduce us to the management of big data in our context. Please, Igor.
Okay, thank you so much. As you can see on the first slide, my goal today is try to present you how did we manage the big data, how did we leverage large volumes of data from the diverse data sources. As my colleague says, I'm Igor Karuza. I come from a company called IGEA. It's a part of bigger group, and we come from Croatia. Today's content is this. What is big data? I'll try to explain in brief. How did we organize the big data process? What did we do? And go step by step and to share our experiences and probably to help you to avoid some steps that we, some mistakes that we did. And at the end, questions. Okay, the first thing is what is big data? Shortly, big data is data that is too large and too complex to process in some, I don't know, standard methods and tools. There are three V's of the big data. The first one is volume. The volume defines the large volumes of data. Usually it's from some kind of sensors that continuously send data to some kind of server or something like that. We are talking about terabytes, petabytes, 100 millions of records. The second V that defines big data is velocity. Oh, sorry. Velocity defines the speed of generation and processing of that data from sensors, of course. And the variety, there are different data formats that could be structured. That's the RDBMS tables that have fixed structure. And then we can have semi-structures, XMLs, JSON, CSVs, and so on. And at the end, we have unstructured data that are images, videos, and so on. We're going to handle the first two ones in this session. Okay, organization. There are some, there's, a little bit, okay, no problem. Okay, the organization of big data process. The first step is defining the goals and the strategies. Then we have to manage the data collection, processing, and storage of the data. We have go through the data quality process, and then we have to visualize the data and give to the users to access it. And in the end, we have to maintain and scale the system and handle the security. And of course, when we are talking about big data, it involves always continuous improvements in the process. To ensure that process, there are three points. It has to be efficient. It has to be efficient, scalable, and aligned, of course, with the business goals of the company. Let's go step by step. The first step is defining goals and strategy. The primary goal is to provide access to heterogeneous data sources through a single point. Of course, we have two interfaces. One interface is user interface, it's UI UX. And the second one is machine, it is API. The secondary goal is data quality control. Of course, all the data that comes from the sensors is not controlled. So we have two types of controls. One type is automated schedule control, and the second one is also automated, but it can be called on demand. Of course, we have to have some strategy. The main goal is to normalize those heterogeneous data sources and use as simple data model as possible. Because everything, when you are handling the big data, each and every mistake will pay back at the end. Of course, the second point is to define which ETL tools that we will use to collect, transfer, and storage data. And in the end, we have to store the data of course, we have used the RDBMS, and we'll show in the next steps what we choose. Okay, of course, we have to have some interfaces, as I already said. You have to have, I don't know, some kind of lightweight web-based solution with some kind of library that could render that a big amount of data. Step 2 is data collection. Okay, we have two types of data sources. One is numerical data that is collected at micro location of meteor station. Of course, I have forgotten to say that we are talking here about meteorological data. We have the sensors and we have the humans that are collecting data. Of course, you know the difference between those two. Besides the numerical data, we have raster data. Okay, we have some imagery, radar, satellite, and we have, of course, numeric models and analysis like Aladdin, Inca, and so on. Okay, there are two data types that we have managed through this project. This is the structured data that we have collected from, I don't know, some other databases, and we have semi-structured data that are provided from the sensors. That's XML, CSVs, and so on, GeoTIFFs, and so on. Okay, when we are talking about numbers, okay, we have 10-minute data. We have two types of data, source data and aggregates. Let's say when we talk about 10-minute data, we have about 3 million records per day. But when we are talking about 1 second data, it's about 350 million records per day. That's enormous data store. That's an enormous amount of data. The other data that is collected is, let's say, 1 day data, daily based data. It's collected from the humans, and of course, that's enormously smaller amount of data. This is 0.05 million records per day. And if we are talking about less resolution, it's about 0.1 million records per day. Okay, we have raster data. In that case, we are talking about gigabytes, let's say 2.5 gigabytes per day, and 0.3, and I don't know, about 3 gigabytes per day. Okay, best practices. Always use, if you have some kind of sensors, always use proprietary manufacturer software, because it is been proven, it has been working under all the conditions, and don't invent hot water, please, as we did. So store the data that is collected from sensors, store it on the file system, maybe SFTPs or something like that. Of course, there are a lot of risks when data is being collected from the sensors. We use, of course, 3Gs, 4Gs, 5Gs to connect to those stations. And there are almost, like in summertime, during summertime, like now, there are congestions in networks. So, okay, we have problems with data transfers. If the provider gives you the REST API or something like that, don't use that, because on the stations, they have weak hardware and they cannot collect the data as you wish to do. So maybe we can talk about that a little bit later. Okay, those are the two types of data that we are collecting. This is the XML type, this is the CSV type. And okay, there is step 3. You have to choose ETL, a magic word that defines extract, transform, and loads of data. Okay, first you have to define the transformation process, define the input performance, CSV, XMLs, and so on. You have to know which data you are processing, numerical, spatial, raster, and so on. Be sure what is the frequency of execution. It has to be aligned with the data collecting frequency, and then define where you have to storage the data. The mapping is maybe the most important the most important step of this process, because you have to map the input to output, and be aware that there are some complex mapping in that process. Okay, step 3 is ETL tool selection. Okay, you have ready-made solution, of course. I don't want to mention which one are those. You can Google it. Pros, wow, you have visual representation in the ETL process. You can, I don't know, connect those dots, everything, and collection of ready-made, you have a large collection of ready-made components. You have the quick results. Wow, super. And then you come to, I don't know, to execution. If you have some complex processes in the ETL, it's, I don't know, it takes a lot of time to implement in ready-made solution. And the most the highest con is insufficient fine-graded control over hardware resources, because you have many ETL tools that are being processed at the same time, and you have to take care about hardware resources. Ready-made solutions just grab the memory and that's it, and then use your own hardware resources. So it's not okay. Okay, then we move to custom-made solution, programming language, and some kind of library. Let's say it's Python, and I don't know, some library that uses something like pandas or something like that. Okay, you have fine-graded hardware resources control. That's nice. You have vectorized processing. Okay, I won't get into that. You can Google it. So just for mention, but there is a con. There is no write. You have to write your own code, but there is no visual representation. Sorry, but it's just code. Okay, configuration. Each and every station doesn't have all the meteo parameters that are being collected, so you have to have one configuration for multiple stations, or you have to have, I don't know, if you have 10 stations with different configurations, you have to have 10 different configurations. The configuration defines input and output relationship. It contains all necessary information about execution of ETL. It's applied, as I said, to one or more stations. Okay, step 4, data storage. Nothing special, star schema architecture. It's commonly used in data warehousing. In the center, there is fact. In this example, it's a measurement. It's being defined by timestamp and the value. Let's say if we are measuring temperature, then it's temperature 10 degrees at, I don't know, 10 p.m. and so on. The other dimensions are meteo measurement value, meteo measurement element, sorry, station, and the status of data, which is most important. I will tell you more a little bit later about that. Okay, storage, nothing special. The little big elephant, so PostgreSQL. Okay, what do you have to do in the Postgre? Don't use referential integrity, please. It's the road to hell. So use the partitioning. See as your data is being, I don't know, you have to partition in the way that you will organize your data. It's a session for itself. Please use aggregation on sensors or in the system. Use retention. Retention is deleting the old data that is not necessary for being stored on the system. And you always have a fast and slow disk and so on. You have to organize which data is being, I don't know, accessed more frequently, and which is, I don't know, more less frequently. So organize that also. Step 5, really important, data quality control. Okay, processes. I import my data. I run some automatic quality controls. We have 2 types of controls. There are basic ones that if this data is had a frequency of 10 minutes, so we have basic control that runs every 10 minutes. Data is being controlled almost in real time. And you have some extended quality control that is being executed each day at the end of the day. So As output, you have daily reports, and then it comes to the manual work when you have the user interface for manual quality control. Okay, those I won't explain in details, but these are 15 type of statuses. You have from uncontrolled data, unofficial data. Unofficial data is the one that is being that automatic control has passed through automatic controls, and in the end, this is mistake here. This includes also this one. Now I can see the official data that is being controlled by the real people. Okay, 5 minutes. Okay, this is the process of the control. On top stays, I don't know, inconsistent, suspicion, incorrect, and missing data, and through the controls for the unofficial data. Okay, this is the UI for the manual quality control. And in this example, you can see the 10-minute data on top that is being used, and this is data that is in retention. This is 1 second data. You control this point by looking at the source if there's something suspicious. Okay, visualization, geographical table view, charts, REST API. This is just the organization to teams. I think there are 400 Meteo elements that are being collected, so we have to group them in some way. This is map-centric user interface. On the left, there are teams, there is timeline, and you can see the stations and Meteo elements that are being selected from on the left. Okay, this is also the map-centric view. Okay, we can visualize raster data, of course. These are not just nice pictures, but when you click on the location, you get the identification of that raster. This is just graphical view, nothing else. This is API through Open API Swagger. Okay. And step 7, maintenance and scaling. Regular monitoring, it's essential, really, for this kind of system to work smoothly. We have VM environment, virtual machine environment, so we can expand our resources as needed. Load balancing also is being implemented on some components. Security, okay. Our client has wanted to get fine graded access. That means it has 3 different stages of definition of security. You just define from which station you want to see the data, which elements, and which statuses of that data. As you have seen before, the data from the input from the beginning to the end passes through the different statuses. So different user groups can see different station, meta elements, and so on. And of course, continuous improvement. We are always monitoring the database with some kind of, we are doing the log analysis of database by using some software called Badger or something like that. Then we collect the peaks of the sequels that are being executed, and we try to optimize it as much as possible. Okay, that's preventive, and this is the corrective. When the users, based on user feedback, we do the performance, we do the optimizations. And that's it, shortly.